I really do not know why it is very difficult for students to do qualitative analysis successfully. It's actually not really difficult. Hello, good afternoon. I'm going to be explaining from the scratch how you attempt the WAEC practical, WAEC qualitative analysis practical. Okay, so you're welcome once again. I'm the educator mom, a full-fledged scientist. So I have observed over time that students have difficulty in identifying sorts or in the way they record it. As I usually tell my students, one of the best ways to understand how these things works is for you to understand the theoretical backing. Alright, you must have a mindset of what type of salt it is by the color of the salts. So here is the table of the appearance of salts. So you check it out. You can pause the video and check it out. So one after the other, let's look at what these salts, how their colors are. When you add water, what you're supposed to look out for is solubility. What you're supposed to look out for majorly is solubility in most cases. So you should also go and learn your solubility table. If you need help on that, you can comment below. So these are the white salts that I want to test. Okay? So I'm going to be using this as an example. So the first one, this sodium hydroxide. See what I'm saying? This is a white gelatinous precipitate. A white gelatin. You can see how it is. Look, not so white, sticky. A white gelatinous precipitate. So this is what? Either Zn2 plus or Al2 plus. So in excess. See, it's clearing up. At times, it does not go immediately, but if you know what you're doing, you'll be patient with it. And that thing you can see in solution. Still on the first one, if I put ammonia solution, this is still a white gelatinous precipitate. Then excess ammonia. You see it's clearing up. Once you put it, there's a reason why they said excess. You begin to shake it. So, as you can see, it has dissolved. So that is telling us that this is zinc. It is soluble in excess sodium hydroxide, also soluble in excess ammonia. Let's check the second one. So this is aluminum solution. Aluminum. Sodium hydroxide. In drops, gelatinous. In excess, soluble. You see? So this is aluminum. In drops, gelatinous. In excess, you see, it became more cloudy. It did not dissolve. No matter how much you shake it will not dissolve, and it will go. You will see it will settle. Instead of clearing up, it will become thick and settle. That's how to know that something does not dissolve. So this is aluminum. It does not dissolve in ammonia, but zinc does. Now let's go to the powdery ones. This is a lead solution. You see? Very different. Can you see? This one is white. Can you see? White. It's different from that one that was jelly-like. Look at it. Powdery. 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 Okay? So, in excess ammonia does not dissolve. So, in drops and in excess, lead salt does not dissolve in ammonia. You see? Lead salt. Look at it. does not dissolve. Does not dissolve. So let's test that lead using sodium hydroxide. In drop, still a white chalky precipitate. In essence, can you see? Dissolves. Dissolves. So that is lead 2 ion. Now the last one of the white. This is calcium. Calcium in sodium hydroxide. A white chalky precipitate just like that. In excess, can you see? Does not dissolve. That is a typical property of calcium. A white chalky precipitate is observed. The precipitate is insoluble in excess. Now, in ammonia, if it is calcium, no precipitate. It gives no precipitate in ammonia. Okay? No precipitate in ammonia. That's to show you that it's calcium. You can see if you do all these things very well, you have no business, as in you will have no issues. Know what the answers are before, then when you test it, it fits in. So now, these are the transition metal salts. Let's test them. Let's go with this first. Sodium hydroxide. This is reddish brown gelatinous precipitate. See the gel. Reddish brown gelatinous precipitate, that's iron 3+. In excess, it does not dissolve. Precipitate does not dissolve. That's iron 3+. Let's test it with ammonia. That's a solution with ammonia. Reddish brown gelatinous precipitate. In excess, the precipitate does not dissolve. Okay, that's iron 2. Iron 2, whether it's sodium hydroxide or in ammonia, the report is the same. White, reddish brown gelatinous precipitate, insoluble in excess ammonia, insoluble in excess sodium hydroxide. I told you that some iron 2 can also be reddish brown in terms of color, but how we distinguish it is when we test it. So this solution is supposed to be iron 2, and if it's iron 2, it's supposed to give us in sodium hydroxide, you see, a dirty green. This is like army green. They call it dirty green gelatinous precipitate. In excess sodium hydroxide, it does not dissolve. Let's try it with ammonia. Ammonia. A dirty green gelatinous precipitate, insoluble in excess. So now let's go to the last one, which is copper. Sodium hydroxide, blue gelatinous precipitate.
Somebody is cooking. She's cooking.
What's up? How was your exam? Precipitate does not dissolve. That's copper 2 ion. Let's try it with ammonia. So it's still pale blue gelatinous precipitate. Then in excess, it dissolves to give a deep blue solution. It dissolves to give what? A deep blue solution. So, if you have any question, don't hesitate to ask me. Alright? Thank you. Don't forget to like me. There are still more WAEC series coming. Thank you. Bye.